Hello, my name is Amy C. Oliver. I'm the Visitor and Science Center Manager at the Smithsonian Institution's Fred Lawrence Whipple Observatory. Thank you for joining us today for Storytime. Today, we're reading Astrophysics for People, Snooks, Snorks, and Sneeples, an educational parody by J.G. Kemp. From quarks to snorks, to clusters of fluff, to the blackest black holes, and other fun stuff. There are things that we know, great things we've uncovered, marvelous, wonderful things we've discovered. Let me share them with you. I know you will find that it's marvelous, wonderful food for the mind. Dr. Snoit, this is great. I'm ready to know. Start up this astrophysics show. Marvelous, wonderful, hop in my car, and I'll teach you, my friend, how to build a star. Let's begin with the fact that we're stuck to this earth, weighed down to the ground by a force that is worth even more when something is made of more mass, like the 10-mile tail of a giant zong's ass. The more stuff there is, the stronger the force. This is why mountains weigh more than a horse. Or why a cloud of stuff up in space gets all pulled together in the first place. Small clouds of stuff just floating around grow bigger and bigger, from specks to mounds, to chunks, to rocks, and even to moons, and planets the size of a trillion prunes. Now keep adding stuff, more and more mass, more than ever before. And stronger the force it becomes with every speck, with every crumb. 1,000,000 Earths could fit in our sun, or maybe even 1,000,001. Bigger and bigger and bigger, I say, and suddenly night ignites into day. So much mass has built us a star that is bigger and brighter than even these nar. As we added more mass, row by row, that force, call it gravity, strong did it grow, and the heat and the pressure inside got so great that something new happened, something first rate. What happened? What happened? You've got my attention. Please tell me of this star invention. And what is this stuff? Of what are stars made? Is it goop or sloop or sweet lemonade? And would 1,000,000 Earths turn into a star if you strung them together on a cosmic guitar? Or what if you had 10 zillion zonks and zipped them together with gaggles of gonks? Then would you have built a star? Or maybe just something that's really bizarre? What is it inside that makes a star glow? What is it? What is it? And how do we know? Back to Earth, come with me, and I will explain. Back to Earth, come with me. It's really quite plain. Let me show to you something that's really quite neat. Let me show to you something that's, oh, such a treat. Now, when you heat up some stuff so hot that it glows, and look at that light through a prism, it shows that light is made up of a spectrum of colors like red and blue and so many others. Strange lines you will see through this prism of yours. Now heat up more stuff from 10 different stores, and you'll find that each thing has signature lines. And you'll find that deep down, there are 92 kinds. 92 elements make up all stuff. Stuff that is smooth or brittle or rough, like copper and zinc, these make brass. And silicon, oxygen, these make glass. Gold is an element, and helium gas. And hydrogen, which is the gas that you pass. And guess what? When you look at the light from a star, no matter how big, how near, or how far, through a prism you'll see the very same lines, the very same colors, the same bright designs. The stuff that's on stars, so hot and so bright, is the same kind of stuff that's on Earth. That's right. And not just on stars, but all over the place, on planets and comets and scattered through space. The same kind of stuff that makes up you, makes galaxies far, far away. It's true. But there's one more thing that's, oh, so essential. if you want to make something with stellar potential. You see, it just so happens that most of this stuff is hydrogen gas. There's more than enough. 73% of the stuff all around is hydrogen gas, and that is profound. Hydrogen, yes, a most simple thing, like letters in a word or beads on a string. Hydrogen, yes, it's element 1. And this is what happens deep down in the sun. You see, in a star, that hydrogen stuff, it gets crushed together like a mountain of fluff. And so strong is the force that it fuses that mass. It fuses that mass and it makes a new gas. The simplest thing becomes something new. Element 1 becomes element 2. But most magic of all, when this fusion sticks, a great burst of light comes out of the mix. Some of that mass, a teeny small piece, has turned into energy and is released. The star lights up, it glows and it glows. For 10 billion years or so, we suppose. If the star is about the size of our sun, do you have any questions? Maybe just one?
Dr. Snoit, you said there are clouds up in space. Where do they come from? This space cloud race?
Ah yes, I did say that. But before I explain, we have to go back. Way back in time, to the very beginning, before Earth was here, and let alone spinning. Way back when everything, all that you see, was crammed into space the size of this pea. And everything, all, was energy of the highest density. Then 13 billion years ago is when it began, this universe show. You see, that pea grew, inflated, we say. Bang! It got bigger, and fast, by the way. And a funny thing happened. Small bits popped out, like quarks and gluons and zibbledees-outs. And those quarks grouped together in groups of 3 and made things called protons. Now do you see? And protons make elements like bricks make a wall, and one proton makes hydrogen, the smallest element of all. So all that hydrogen, yes, it's true, came from that big bang as the universe grew. And that hydrogen gas made the first clouds in space, and gravity worked, pulled them into place. Into big and bright and fast-burning stars that turned hydrogen stuff into helium bars, and helium bars into carbon stew, and carbon stew into oxygen brew, and oxygen brew into silicon soup, and silicon soup into iron goop. And once those stars had made all that iron, they blew up, kaboom, blammo, cab-iron! And all those elements spewed right out, scattered back into great big clouds, no doubt. And guess what, my friend, formed out of those clouds? More stars, it's true. Crowds and crowds. Whole crowds of stars that clumped up together into galaxies, clusters, better than ever. And some stars lived and died and exploded and built more elements. Supernova, unloaded. Then back into dust. Space dust, space clouds. And one of these clouds has made me most proud. The space cloud that swirled together and formed our own sun and its planets. Don't be misinformed. Our very own Earth, its dirt and you, and Zooblezix and Snickersnooze, the stuff we're made of, our hands and feet, once lived in a star. Hey, that's kinda neat.
Kinda neat. Kinda neat. It's amazing, I'd say. It's totally great. A wonderful play. But doctor, are you just making up words? There are so many words that I've never heard. And one other thing, you said stars exploded, and our sun is a star. That's one thing I noted. Is our sun, our wonderful sun, to blow? Someday in the future, will there be a sun snow?
Great question, my friend. Great question indeed. Let me tell you some more before we proceed. Like zonks and gorks and snuffs holding snars, there are many different types of snars. It depends, you see, on the size of the beast and how much mass showed up to the feast. Little red stars eat steady and slow and will slowly burn out in 1 trillion years or so. Yellow stars, like ours, our very own sun, are bigger but won't quite explode when they're done. Even bigger stars, about 10 solar masses, eat 10 times as much hydrogen gases. These big stars burn fast and bright and hot and blue and even white. Just a few million years and then it is these big stars that really kablem. And when they blow, like I mentioned before, it makes all that stuff that you get at the store. So don't worry, my friend, our sun won't blow up. At least, not in the way big stars go kab-up. In 5 billion years, our sun will morph and live out its days as a little white dwarf. But don't you fret, we'll be just fine. 5 billion years is plenty of time.
Doctor, I have another question. How much can stars eat before indigestion? Can stars get bigger and bigger forever? Is there an end to this stellar endeavor? Can you add 1 million suns in a ball? Or 1 million more? What is the call?
Great question, my friend. You're very astute. Much more than Zob from Zob Zob Galoot, who never asks questions and never learns more, and lives every day like the day lived before. Your question is fine, and answer I must. There is a high end to the stars we've discussed. For the bigger and bigger and bigger the mass, the stronger and stronger the force, alas. And that force gets so strong, a funny thing happens. The whole thing collapses, and then it blackens. That force is so strong, the mass is so great, that not even light can escape the great weight. And it forms a supermassive black hole, a hole so black that it shudders my soul.
Wow, Dr. Snoit, I would like to know more about these holes you mentioned before. These holes that you say are so very black that nothing escapes, nothing comes back. What if these holes crash into each other? Does it ripple through space? Ripple, my brother? And what about stuff I've heard called neutrinos? What are they? Is it something you win at casinos? And what about wormholes and mesons and such? Is that stuff real? Am I asking too much? What are quasars and pulsars and matter that's dark and hadrons and muons? Are those at the park? And bosons and massive cosmic rays, where are they found in this science-y maze?
My friend, all these things are so very neat. And in science, your training is never complete. So ask away, ask away. Each question makes more. That's how it works when you start to explore. The most interesting stuff is in the details, like the endless layers of a quadrupillar scales. Keep asking those questions and go read a book. Start down this path and you will be hooked. And if you're in a hurry, there's a book just for that. Astrophysics is great. Just look at my hat. Thank you again for joining us for Storytime. Again, I'm Amy C. Oliver, Visitor and Science Center Manager at the Smithsonian Institution's Fred Lawrence Whipple Observatory. You've been listening to Astrophysics for People, Snooks, Snorks, and Sneeples, an educational parody by J.G. Kemp. Thank you again for joining us. Have a wonderful day. Keep engaging with science, and always, always keep looking up.